Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. So, in the previous lecture, we were discussing about the basic concept behind the phenomena of isomerism, and then we discussed shortly the types of isomerism, that how it can be characterized into two main groups named as structural isomerism and stereoisomerism, and then we discussed or named the different types of each of these categories. So the first group was structural isomerism. So in this lecture, we are going to discuss the types of structural isomerism in detail. So the first type I told you was chain isomerism. So this chain isomerism, it can be defined as the type of isomerism that arises from the difference in the carbon skeleton of compounds. So the very first example we discussed in the first video was of chain isomerism, which was that here is a molecular formula C5H12 of pentane, and I told you that it can be written as this, or it can be written as N-pentane, isopentane, and finally neopentane, right? So here I am just writing it in this form. So another example which we can also discuss is for butane, which will be C4H10. So it can be N-butane, or it can be isobutane, right? So there are two examples of chain isomerism. So in chain isomerism, there is a difference in the carbon skeleton of compounds. So the second type of structural isomerism was position isomerism, in which I told you that there will be difference in the position of substituents attached. So the carbon skeleton, it will be same, but there will be difference of the attachment of substituents. Let's say we have, I say dichlorobenzene, dichlorobenzene. So, and I ask you to write the structural formula. So you can pose three different structures, which can be ortho dichlorobenzene. It can be meta dichlorobenzene, or it can be para dichlorobenzene. So 1,2 dichlorobenzene, 1,3 dichlorobenzene, and 1,4 dichlorobenzene, they are positional isomers. And the difference between them is not in the carbon skeleton, rather, the difference is in the position of the substituents or the functional groups that are attached. So here their relation is 1 2, here their relation is 1 3, and here their relation is 1 4. Another example which you can take is, let's say, 2 butene and 1 butene. So here there is the difference of the position of this double bond, right? So this double bond, it is also a functional group. So these two are the types of positional isomers. The third type of structural isomerism, which I told you, was functional group isomerism. Functional group isomerism. So in this type, there will be difference of functional groups. Let's say I write a molecular formula as C2H6O, and I ask you to write the structural formulas of this molecular formula. So they can be written as CH3, CH2OH. So ethyl alcohol, or it can also be written as an ether. So this is dimethyl ether. So this dimethyl ether and ethyl alcohol, they have a similar molecular formula, but the difference is in the functional groups. Here there is an alcoholic functional group, where here is an ether functional group. So in case of the functional group isomerism, there is a difference of functional groups between the two isomers. So let's consider another example. Let's say I say a molecular formula C3H6O, and I asked you to write the structural formula, that formulas that can be posed from this molecular formula. So they can be written as CH3, CH2, C double bond O H, or it can also be written as like this. So uh, in the first structure, the functional group, it is an aldehyde, and in case of the second structure, the functional group, it is a ketone, right? So this propionyl aldehyde and acetone, they are functional group isomers of each other. The fourth type of structural isomerism I told you was metamerism, in which the arrangement of carbon atoms around a central atom is different. Let's say we write this structure, right? Sorry, we have to add another carbon. Let's say we write this structure, and this position of carbonyl, it can be here at 2 position, or it can be at 3 position as well, right? So first one is the methyl propyl ketone, and the second one is the diethyl ketone. So these two are metamers of each other. So here, what is the difference is the arrangement of carbon atoms around a central atom, which is the carbonyl here in this case. So in first structure, the here there is one carbon, and here there are 3 carbons. However, in the second structure, here there are 2 carbons on each side. So such isomers where there is a difference of the arrangement of carbon atoms around a central atom are called metamers. So another example which we can discuss in this category is related to ether, like the methyl propyl ether or the diethyl ether, right? So diethyl ether and methyl propyl ether, they are also metamers of each other. So there is only the difference of the arrangement of carbon atoms around central atom. Finally, the last type of structural isomerism is tautomerism. It is a very unique type as compared to the others. And the reason behind this uniqueness is that all the types that we discussed before, they are static. Like one isomer, it cannot interconvert into another. However, in case of tautomerism, there is interconversion of structures, and it is especially observed in the cases where there is active methylene present. So let's say we write this acetone. So you know that this carbon, it is the proton attached on this carbon, it is acidic. So it can also exist in the other form, which can be written like this. So what has happened over here is that this proton, it has shifted to the oxygen. So these two forms they can be proposed. So this is tautomerism, where there is the transfer of a certain group inside a structure. So these two they can be interconvertible. They are interconvertible. Like this proton, it can go back to this CH2 group and it can reconvert. It will be reconverted to the main acetone form. So these two forms they are interconvertible. So tautomerism is unique in this case, that it is dynamic, whereas the other types which we have discussed previously, they are static. So they cannot. So in the other case, the isomers they cannot interconvert into each other, but in case of the tautomerism, the isomers they can interconvert into each other. This tautomerism, it can also be categorized into two main types. The first one is the cationotropy, and the second one can be aninotropy. In the case of cationotropy, the moving group inside a structure will be a cation. Like here in the above example which we have discussed, the moving group is a proton. The proton has a positive charge, it is a cation. So this example, it can be categorized into the cationotropy type. The second is the aninotropy. So as indicated by name, the moving group in this case will be an anion. Let's say we discuss an example over here. This cinnamyl alcohol. This OH, if it shifts over here, this bond will break onto oxygen. Another type, it can be written as like this. So in this case, if you observe the moving group, it is anion. So how it is an anion? Because OH is moving, hydroxyl group. So hydroxide ion, we can say. It has a negative charge on it. So these are two main types of tautomerism. First one is the cationotropy and second one is the aninotropy. So in today's lecture, what we have discussed is the different types of structural isomerism, which are chain isomerism, where there is a difference in the carbon skeleton. The second type was positional isomerism, where there is the difference of the position of substituents. Third one was the functional group isomerism, where there is a difference of functional groups. Fourth one was the metamerism, where there is the difference of the arrangement of carbon atoms around a central atom or a group. And the fifth one was the tautomerism, where there is the shift of a certain group inside a structure, and it is unique in a way that tautomerism is dynamic, that the two isomers they exist in dynamic equilibrium and they are interconvertible. They can interconvert into each other and they are always interconverting. So, this was all for today. In the next lecture, we will start discussing about the stereo isomerism. So, see you in next video. Allah Hafiz.